Hey, geometries. In this video, I want to take a look at lecture 3.1, which is all about parallel and perpendicular lines. But before we do that, it's a good idea to just review these three undefined terms: point, line, and plane. And so do you remember what a point is? Well, that's right. It is a location with no space. It has no size. There is no dimension to a point. It is just a location in space. So what's a line? A line is a straight path with no thickness that extends forever. So that is considered one dimension, right? Length is one dimension, anywhere along this line. The last one, of course, is a 2D figure called a plane. And a plane is a flat surface with no thickness that extends forever. So that's kind of the review. We're going to review these undefined terms, and then that'll help us make sense of the rest of our world. All right, so let's identify parallel, perpendicular, and skew lines. Skew might be a new term. And then identify angles formed by two lines and a transversal. So there's a ton of vocabulary. Geometry is full of vocabulary, very technical terms. You're going to have all these vocabulary listed and understood by the end of this chapter. Please get this table into your notes. I want to see that you have this table in your notes. It's on page, let me flip there right now, 3.1. Sorry for the delay. I could pause the video, but I'm not going to. It's on page 146. So this is on page 146. So please get this table into your notes. What this table is saying is the following. Parallel lines, page 146, are, number one, they use this symbol. This symbol means parallel lines. They are coplanar. They exist in a plane, and they do not intersect, such as AB and EF, right? Or even EF and CW. You could make a plane between those 4 points, and those two lines would be parallel. Perpendicular. Make sure you get this symbol for perpendicular in. They intersect at 90-degree angles. So, of course, these AE and BA are perpendicular. Skew lines are not coplanar. And so that's the big difference here. They don't intersect, and they're not in a plane. So if I said, let me just use my little highlighter, my magic highlighter here. You guys like highlighters, right? All right, Peter, what color highlighter do you want? Pink. Very good. So this pink line, EG, right, is skew to Sohan. What line color do you want? You want the blue? All right. To this one over here, CW. So these exist, right? Oh, look at that, how it automatically straightens out, right? They exist in different planes, and they don't intersect. That's what makes them skew. The last thing we need to talk about here is parallel planes. So this is the idea that this side here, as in A, C, G, E. So this plane right here is parallel to B, W, H, F. Right? So these two sides are parallel. And that's kind of the big idea there. All right, segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. All right, so what they want you to do here in this problem is identify each of the following, a parallel segments. All right, Cody, what do you think? Which two? Was that BF and DH? That's correct. That is an example of a pair of parallel segments. All right, now let's see if we can figure out a pair of skew segments. Again, skew means they're not in the same plane. Okay, Rihanna, what did you say? F, J. Okay, now let's pick one that is not in this plane. Oh, CG. That's right. They don't intersect. Let me do this. Skew will be gold, right? Blue will be parallel. We'll do green will be perpendicular. All right, let's do that. All right, Rachel, could you give me a pair of perpendicular segments? Oh, very good. You said these corners, right? Any one of these corners. So EJ and FJ. Very good. Those would be perpendicular. Awesome. Last but not least, parallel planes. I got a call coming in. I'm going to have to pause. Okay, we're back. Rachel was selecting a pair of parallel planes, and she said, hey, Mr. Rising, isn't the top and the bottom, aren't those both parallel? And of course they are. So I would say plane B, is that E or F? E, D, C, right, is parallel, and you need to go in the same order. F, J, H, G, back to F, right? And so those are my parallel planes. So try this right now. Take your pencil, in my case I have a ruler, and put it perpendicular to your desk. So hopefully at this point you've got it just balanced just right. Now how do you know your pencil is perpendicular to your desk? Well, if you take some kind of object that has a right angle on it, oh boy, can I balance a ruler on a piece of paper? I don't know, this could be trouble. No, that's not going to work. But anyway, if it's exactly 90 degrees, if I take a sticky note, for example, right, and I put it right at the base, like as in this diagram here, it appears to be perpendicular, but it could also be tilted at an angle, right? So it could be perfectly perpendicular, or it could be at a 90-degree angle to this purple line, but leaning over. So how do you know that it is truly perpendicular to a plane? Well, here it is. When a line is perpendicular to two lines on a plane where they intersect, so this line right here and this line right here. So this is two lines intersecting. Two lines intersect on, go ahead, Bjorn, say it, a point. Very good. Now, if this segment or line is perpendicular to both of these intersecting lines, then I know it is perpendicular to all lines on that plane, right? And now you know your pencil is perpendicular. Here's the rule. Through a given point, there passes one and only one line perpendicular to a plane, and through a given point, one and only one plane perpendicular to a line. Kind of interesting stuff there. The next thing I need you to get in your notes is on page 147. I know we're doing a lot of vocabulary. We've got diagrams. But having this picture and these terms and the examples that go with them, I think are really important. And we'll do some more work on this on Friday. But here it is. A transversal, in this example, is, we're going to call it T, is a line that intersects two coplanar lines at different points. So again, T intersects S and R, right, at two different points. And I'll just put a little intersect right here and right here. Well, that didn't show up very well. Let's try blue. There we go. Nice dark blotch. You guys love it. Okay, now here's the big concept. When you have this situation of intersecting lines, let me erase everything. Corresponding angles lie on the same side of the transversal, whatever, left or right, and on the same side of the corresponding lines, R and S. So, for example, 1 corresponds to 5. You can think of it as the northwest corner of this intersection and the northwest corner of this intersection. 2 corresponds to 6. 7 corresponds to 3. And 4 corresponds to 8. Again, I like to think of it as like northwest, northeast, southeast, southwest kind of thing. Those are your corresponding angles. The next thing we need to talk about, alternate interior, are non-adjacent angles that lie on opposite sides of the transversal between R and S. What? Between R and S? Okay, so 3 and 6 are alternate interior angles. So are 4 and 5. See how those are alternate? Alternate means opposite side of transversal, interior between these lines. Alternate exterior angles, then of course, 1 and 8 or 2 and 7. Cool. Seems to make sense. Again, alternate, other side of the transversal, exterior, outside of those lines. And last but not least, same side interior angles could be 3 and 5, or it could be 4 and 6. We're going to do more work on this on Friday, but I think it's important to get this information down. And of course, this is what you need to then be able to do, is you need to look at a diagram and say, okay, well, what are corresponding angles? Well, 5 corresponds to 7. 5 is the southwest corner, 7 is the southwest corner. Give me another pair. Daisy, go ahead. What's that? 2 corresponds to 4. Very good. So yeah, those are corresponding angles. You got it. All right. Alternate interior angles. Charlie, go ahead. Give me a pair of those, please. Alternate interior. 6 and 3. Very good. Or you could have said 2 and 7. Fantastic. All right. Alternate exterior. Callista, can you give me a pair of alternate exterior? You want the pink? Okay. 1 alternate, so it means it's got to be on the other side. Exterior, 8. Oh, very good. I like it. And Matthew, could you give me another pair of alternate exterior? 5 and 4. Fantastic. All right, last but not least, same side interior angles. Okay, Chandler, you're up. Did you say 2 and 3? Right on. And Cyrus, can you give me another pair? 6 and 7. Oh, you guys, you're nailing it. Love it. All right. What can often be confusing is what a transversal is. So here it is. The transversal for a given angle pair is the line that connects the vertices. Again, a vertice is where rays come together or lines come together to form angles. So what segment or what line connects the two angles? That's really the big question in determining the vertice. So here it says identify the transversal and classify the angle pair 2 and 5. All right, well, where's angle 2? There's angle 2, and here's angle 5. So what is the transversal? Well, this line here, N, line N connects angle 2 and angle 5. So I would say, of course, my transversal is line N. And then what kind of angle pair are 2 and 5? Well, they're in the interior. They're between M and L. Okay, so they're definitely some kind of interior. And let's see, well, they're on the same side of that transversal, so they're same side. Why am I trying to write this out? They are same side interior angles. I hope this lecture was helpful. Again, today we wanted to identify parallel, perpendicular, and skew lines, and then identify angles formed by two transversals. I think we've just nailed that. You guys have done a really good job. We're going to hit it hard tomorrow when we talk about parallel lines.